And so here we're looking at advanced manufacturing for tailoring performance for the individual user. And we had this hypothesis that with multi-material printing, we could create new types of prosthetics that had enhanced functionality. So with prosthetics, you can imagine they're needed for nose, arms, and legs. They need to match the physiological properties of the body. You have the challenges with the performance and the practicality. And so one of the things that you need in prosthetics is they need to be strong, but they also need to be robust and be able to displace and be flexible as well. So our strategy here is we're mixing a stiff ABS polymer with a flexible thermoplastic urethane polymer. And so we printed different arrays of honeycombs, which had either full ABS or full TPU or a TPU band inserted into the ABS. So I'm going to show you the mechanical testing setups here. So for all of those structures we designed, we put them between compression plates and applied force to them. We did that both in plane and out of plane. So if you design a honeycomb, it's going to be stronger in the out of plane compression direction. And so whenever we tested these, you can see in this video, the flexible material is going to take the load and displace first. And then you have that stiff material that's going to have the higher energy absorption for if the load is going into failure. And so the reason that this is good for prosthetics is whenever you're just walking and you have light loads, you have that flexible polymer that's able to displace and recover over and over again and act as a shock absorber. But if someone gets into a crash or falls and needs that higher energy absorption protection, after that flexible polymer is through, then you have the ABS that's going to take on more of the load. And I'm going to play this video again. And so in order to assess these, what we really want to look at is the displacement and the energy absorption, which the energy absorption is how much load it can take before failure per displacement. And so whenever we plot these, in the top right, you see a load displacement curve. You can see ABS has a very high stiffness initially and can take a lot of load before failure. But that's all at a very low displacement. Whereas adding that TPU in this system allows you to extend further into the displacement regime. And whenever we look at the energy absorption, you can see that there's this linear trade-off with how much TPU you can add into the system to get that further displacement, but also affecting the energy absorption. So here you could tailor this for different persons and different applications depending on what activities they're going to do. And so where we've been going with the prosthetics next is using that powder printing process, and we're looking at integrating the multi-material systems with joints and different aspects of motion to create the prosthetics that would be optimized for the users.